Today, we'll learn how to solve for an absolute value inequality. But before working with a solution, how to solve for an absolute value inequality, you have to go through some reviewings first. What is an absolute value of a number? If I'm talking about absolute value of 3, what is it? Absolute value of 3 is a distance of the number on the number line that is 3 distance units away from 0. So an absolute value of 3 is obviously number 3, because number 3 is 3 distance units from 0, or number -3 is also 3 distant units from 0. Okay? So once again, what is an absolute value of a number? Is the distant unit of that number from 0. Now, I would transfer that thought to solving for an absolute value inequality. Today, I have an inequality 5. Take away 3 times the absolute value of 2x minus 7 greater than or equal to -10. We have to solve for x. X is the unknown. The rule of thumb is you have to get the absolute value quantity by itself to one side of the inequality. In this case, we will subtract 5 to both sides of the inequality. I do that, I only have -3 times absolute value of 2x minus 7 left, greater than or equal to -15. And then we want to isolate this only, the absolute value of 2x minus 7. So I will divide both sides of this inequality by -3. -3 divided by -3, 1. I have 2x minus 7 with the absolute value left. And over here, I divide -15 by -3. I have +5. And once again, when we divide both sides of the inequality by a negative number, we have to switch the inequality sign. And now this will become less than or equal to 5. So we end up with this less than or equal to 5. And once again, what is absolute value? Absolute value is the distance of the number from 0. Here we have a distance of the number, I don't know what it is, less than or equal to 5. So on the number line, I know that there are only 2 numbers on both sides of the 0, 5 and -5. And those 2 numbers would give you 5 distant units from 0. But here I want to have something less than or equal to 5. So therefore, this expression, 2x minus 7, can only be between 5 and -5. So from here to here, we transform this expression to something without the absolute value symbol. So you could be able to solve for this. And this is called a compounded inequality. So we solve for x. We add 7 here. I have 2x left. I add 7 to 5. I have 12. And I add 7 to -5. I have 2. And then I solve for x. I divide it by 2. I have x. I divide it by 2. I have 6. I divide it by 2. I have 1. And then you have to remember to graph the solution set for this expression. So x now is between 1 and 6. So we shade it in, everything between 1 and 6, and around 1, bracket, due to the equality here, around 6, bracket. And then the final interval notation answer is x belong to an interval 1 up to 6, including 1. and including 6. So solving for an absolute value inequality, rule of thumb, we have to isolate the absolute value quantity. And then we look at this. If this is less than or equal to, we know that this has to be between these two numbers. In this case, 5. So this will be between -5 and 5. And you go ahead and solving. And after you solve to the final step, we graph the solution set on the number line. And then make sure you remember to give the interval notation answer. Okay? And I will show you case number 2 of solving for an absolute value inequality. What if here I don't have less than or equal to 5? What if I still have the same expression? But now I have greater than or equal to 5. How can I solve for this? All right, now we want something more than 5 distance units from 0. More than 5 distance units from 0. I just want to show you on the number line. This is 0. This is 5, and this is -5. And of course, at these 2 points, we have 5 distant units from 0. But if we want to have more than 5 distant units from 0, more than 5 distance units from 0, you go beyond 5 to the right, or we go beyond -5 to the left. So we go to these 2 intervals right here. If we want to go to beyond 5 to the right, we want 2x minus 7 greater than or equal to 5. Or you go here, you go to -5 to the left. We want 2x minus 7 has to be less than or equal to -5. So for this case, we have either or, either greater than or equal to 5 or less than or equal to -5. And then solve for x. I add 7 to both sides. I have 12. I divide both sides by 2. I have 6. I add 7 to both sides. I have 2. I divide both sides by 2. I have 1. And then we graph it. On the number line, I have 1. I want less than. I shade to the left. I have 6. Greater than. I will shade to the right. And the interval notation answer, x belong to -infinity up to 1. Close the bracket. Union 6 to infinity. So I just show you how to solve for an absolute value inequality. We only have 2 cases besides something special. If it's less than or equal to a number, then we have to work it between these 2 numbers. If it's greater than or equal to a number, then you have to split into 2 different cases. One is greater than the number, one is less than or equal to the negative of that number, and you solve. And make sure you have to graph, and make sure you have to give the answer in interval notation. Thank you.